Hello everybody and welcome back to another new lecture. This week we're going to be talking about plumbing systems and this is going to be the final lecture in our module 3 that covers mechanical and electrical and plumbing systems. All right, so this week for your readings we're going to be reading 2 pages out of the ballast reading I posted on Blackboard. All right, so just pages 11 through 13. And then in the textbook, chapters 9 through 11 are what is covered within these notes. So you can read through that. You don't need to go super in depth with your reading. Maybe just skim through it and get all the highlights because they go really in depth and there's just a lot more in there than you really need to know, if I'm being honest. So for the purposes of our class, we're just going to take a generalized overview, sort of high-level look at how plumbing systems work. We don't need to get too in the weeds with all the details about how the systems go together. We just need to understand in sort of a basic general way of how plumbing systems function, all right, so that we know how to incorporate them into our designs and take them into consideration. All right, so let's get started. Interior designers may coordinate with plumbing contractors to determine plumbing system requirements for projects. Coordination helps interior designers know where plumbing fixtures can and cannot be located within a building. The interior designer is not directly responsible for the technical specifications of plumbing components, but they do need a good enough understanding of them to efficiently locate fixtures in a design. For the purposes of this class, we will only take a general look at how plumbing systems function. We will also examine some best practices for locating plumbing fixtures when designing. All right, so just like last week when we discussed electrical systems, this week's lecture and notes are going to be a lot more picture-based and a lot more just explaining how things function as we go through. All right, so let's hop into some of the plumbing basics and get an idea of how a plumbing system actually works when it's integrated into a building. So a complete plumbing system is composed of 3 individual systems, okay? The entire plumbing system as a whole is made up of a water supply system, a waste system, and a vent system. And all 3 of these have to be working together for the entire plumbing system to operate correctly and efficiently. Okay. So first we have the water supply system. So plumbing lines bring water into a building from an outside source. So this could be like your city water supply line. You could be tapping into that. Or if you are in a remote area, say this is just a residence that's in a rural area, not in the city, they might have a ground well that they're tapping into for their water source. And then those plumbing lines distribute the water to plumbing fixtures throughout the building. So if I'm talking about a plumbing fixture, that's just a general term for anything having to do with plumbing that a person is interacting with. So it could be a toilet, it could be a sink, it could be a bathtub or a shower. So whenever a plumber is implementing a water supply system, they're going to be putting in 2 separate plumbing lines that are going to be run to each fixture in the building. So there's one for cold water, and then there's going to be one for hot water as well. All right, so here's a diagram of a basic standard water supply system in a residential application. Okay, and all of this is explained here on this next slide. I'm just going to explain it just by showing you in the diagram itself, but if you want to go through and read all of the points the way the book describes it, you can refer to the following slide and read through that. But basically what we are looking at here is that number 1, we have our plumbing line or our main water line that's coming in from our source. Okay, like I said, that could be a city water supply or it could be a well or something like that. Right? That is coming into the basement of the building here. And another thing about this is its location in the ground is going to be below the frost line. Okay, so there exists a thing known as the frost line. I think I mentioned it maybe previously, but the frost line is basically the point, if you're digging down into the ground, where water cannot freeze. Okay, so basically the soil above the plumbing line acts as an insulator, and when you get deep enough, even in the wintertime at a certain depth, none of the water below a certain depth will be able to freeze. Okay, so what you want to do whenever you're putting in a plumbing system, or what a plumbing contractor would do, is they would install the plumbing line below the frost line, and I think the frost line is around 6 feet or so from the surface. Okay, they will install that below the frost line so that the water coming in will not freeze and cause a pipe burst. All right, so when that is coming in, it comes to this spot right here at number 3, or actually at number 2. This is your water meter. Okay, so if you go in your house and you go downstairs to where the main water supply line is coming in, you'll usually see a meter attached to the main water line, and this just shows your water consumption, okay, for your service bill that you're going to be paying each month. And then our line is coming off of our meter, and it's going then into our water heater, but then it's also continuing onward and branching out to fixtures throughout the house here. Okay, so number 4 is actually our water heater. So we have cold water coming into that. The water heater is going to be powered by gas and electric, and that is going to heat up the water that's inside of it. And then all the heated water is going to be exiting through our hot water line. Okay, so the cold water lines are indicated by the blue, and the hot water lines are indicated by the red. And as you can see, every single one of these fixtures that we have, except for the toilet, because the toilet doesn't need hot water, is going to be getting both water lines run to it. So our washer and dryer has cold and hot. Our sink up here, which I'm assuming is probably in our kitchen, that has cold and hot water supply. Our shower has cold and hot. Our bathroom sink is cold and hot. And then our toilet just has cold because it has no reason to have hot water. In terms of our water heater as well, so what you're seeing here is a water heater that has a tank associated with it, okay, and it actually stores the water and heats all the water inside the tank up and then distributes it. There's also water heaters that are called tankless water heaters, and those are more modern and they're more expensive, but the benefit of them is you can have a constant feed of hot water on demand at any time. So if any of you live in a house that has a tank water heater like this, you're probably familiar with taking a shower, and if you're in the shower for too long, eventually the water gets cold and you lose all your hot water. That's because you have this tank water system that can only distribute the water that has been heated up inside it. So as you deplete that water supply within it that's already been heated up, it has to bring in more cold water, but obviously it takes time to heat that cold water up to the temperature that you want it to be. So if it's not heated up, it can't give you any more hot water, and you end up just getting cold out of the hot water line. All right, but a tankless water system, again, that is going to prevent that from happening. You just get a constant stream of hot water on demand whenever you need it. Water supply lines can take a few different forms. So here are the most common types of water supply lines you're going to be encountering. All right, so first we have lead pipes, and this is one of the oldest types of water supply lines that there is. So these were commonly used in the 1800s up until the early 1900s, but then eventually the usage of them was phased out due to concerns that poisonous lead may leach into the water from the pipes themselves. All right, so people started becoming more health conscious, and they decided to move away from the lead pipes because they learned more about the toxins that are associated with lead, and that got people worrying, well, if our pipes are made of lead, what is that doing for our water supply? Is the toxic lead that is within those pipes actually leaching out into our water and poisoning us? Okay, so they decided it would be best to just phase those out and get rid of them. Here I included this vintage ad that we have here for lead pipes just because I thought it was funny. You save money, make better jobs because lead plumbing requires fewer joints. Okay, them implying that lead pipes are better because they require fewer joints, I just think is funny because sure, that may be true, but then you end up being poisoned by it. So just a funny thing to throw in there. From an age where people didn't really understand the dangers associated with, with that technology that they're using back then. Sort of the same thing as like smoking or something like that. People just weren't aware of the dangers that may come into play because of it. All right, the next type is galvanized steel pipes. So these started being widely used in the 1950s and 1960s as a replacement for old lead pipe plumbing systems. Galvanized steel is steel that is coated in a layer of zinc to prevent rust. And over time, it's actually common for these pipes to get rust built up within them. So I guess just over time, that layer of zinc that is in there preventing that rust from forming is going to get worn away. And as that happens, you can see down here, you get this buildup of a rust compound within the pipe itself. And that is going to block your water flow through the pipe and make them function really poorly. So if these get really old, they just need to be replaced because, if you have poor water pressure, this is usually a reason because of that is just because you have a buildup within the pipe and the water cannot really get through there very efficiently. Next, we have copper pipes. So these began appearing in homes and commercial buildings in the 1930s. The joints that connect segments of the copper pipe are usually going to be soldered together using a lead solder. Some people have also had concerns about lead solder, so the component that's actually fusing these pipes together, fearing that might leach into water as well, but that's still the standard that we use, and typically it's not really that big of a deal because it's such a small amount of lead. It usually doesn't really leach into the water supply at all. Copper is still used today, but it's going to be more expensive and harder to install than newer supply line types. Okay, so we have more modern things than copper that are easier to install, so you don't need somebody who's as much of an expert, and also the material itself is just less expensive to produce. Okay, so copper is usually used in buildings where people value something that's a bit higher quality. A lot of people see copper as a premium material and they may want copper pipes because it's been proven to be one of the best plumbing types throughout history, and it's more expensive and it looks nicer. But again, it's more expensive, obviously, which more modern designs are kind of steering away from it because of that. And also, they can be prone to pipe bursts if the temperature within the building gets too low and the water would freeze within them. These can actually burst and cause big problems. CPVC tubing. Okay, so this is a more modern development. This is it's a type of plastic tubing, and it stands for chlorinated polyvinyl chloride. And this started being used for water supply lines around 1959. Because it's made of plastic, it's going to be inexpensive, and it is a lot easier to install than copper. Okay, so all your joins that you have here, instead of using solder to do all of those, which can be really tedious and it requires a lot of skill, we just use these connectors, and you have a special cement that you're going to be applying to each of those joints, and that cement is going to be fusing all those joints together. Although it is inexpensive, it can also be prone to bursting if water inside it freezes. Okay, so just like I mentioned with the copper, these will burst if the water inside it gets to a low enough temperature to where it can freeze, and it'll then expand and just kind of blow up the pipes. All right, so our last one we're going to talk about here is PEX tubing. So this is the most modern one out of all the ones I've shown you. PEX stands for cross-linked polyethylene. Now, I have no idea why it's called PEX, if that's what it stands for. Seems kind of weird to me, but that's what it is. It started being widely used in the 1980s. Okay, so again, relatively modern. PEX tubing is made of flexible plastic that can be easily bent to make turns. Okay, so if you look at this picture down here, we have some PEX lines, and you can see that they can just easily be bent to go wherever they need to be. Okay, so it's just one long continuous pipe. And you don't have to have a bunch of joints everywhere like you did these other ones. So every time you want to make a bend, you have to put a special joint in here, and it gets really complicated, and it takes forever if you have to, make all these little turns and stuff. So that makes PEX a lot easier to install. You really only need these connectors in places where the plumbing lines are going to branch off and go a different direction. It is a popular choice for modern plumbing applications because it's inexpensive and it's very easy to install. Blue PEX tubing is used for cold water lines, and red PEX tubing is used to indicate hot water lines. Okay, so you can see the colors here and what those are indicating. That's really nice because you can just look at it and know the temperature of the water inside of it. With the other plumbing options that we have looked at, it's a lot harder to tell what is a cold water line and what's a hot water line because just looking at it, you don't have any idea. Okay, but this gives you a nice visual indicator. And it's also common to join new PEX lines to old copper or CPVC lines when doing renovations. So here's a picture down here that shows a copper line and a PEX line, and they are coupled together here with this this coupler or this joint that we have. But that's really common to see in like retrofits and renovations. You'll take the old plumbing, and then when you have to add on new fixtures to the building, say you added a new bathroom somewhere in a house and you have to run new plumbing to the existing copper plumbing that's there, maybe you want to save some money and go with PEX. Well, you have to have a way to tie into the existing plumbing that's already there, and that can be easily done with PEX with these special connectors. So you'll see that a lot in renovations. All right, the next system that we have is our waste system. So the waste system is responsible for removing gray water and black water from buildings. So what do I mean when I say gray water and black water? Well, when we're talking about water that is being used inside of the building, we have three different terms associated with that water. Water that is coming into the house through our supply lines that we will be using, that's clean water or clear water. Water that has been used, but has been used in a bath or a bathroom sink or a washing machine, that is known as gray water. So when you think of gray water, just think of water that has been used by somebody, but it doesn't contain human waste, okay, like feces. And then black water, that is water from toilets, okay, that's the water that contains the human waste. Also, dishwashers and kitchen drains fall into that category as well. So drainage lines, these are usually made of PVC or ABS. Both of those are a type of plastic tubing. PVC, when you see that, it's usually going to be a white tube, okay? and an ABS tube. ABS is just a different type of plastic. Those are usually going to be black, okay? So if you see a black tube, you know it's made of ABS. If you see a white one, you know it's made of PVC. A soil stack. This is a vertical drain pipe that carries black water from toilets, okay? So we're going to be taking a look at what a soil stack looks like in a building here on the next slide. But when you hear a soil stack, just think of your main vertical pipe in your building that is going to be carrying water that has human waste in it. A waste stack, this is also a vertical drain pipe but this one carries gray water. So this just carries water from sinks and showers. It doesn't have any of the human waste within it. All right, just like HVAC systems, waste systems have a tree-like structure, okay? There's going to be a soil stack that sits at the center of the system, and it, along with the toilet drains, are going to be the largest pipes in the drainage system, and those will have a diameter of 4 inches. All other fixtures are going to be smaller. They're going to have smaller drainage pipes tied to them, and the diameters of those are going to range from 1.5 to 3 inches in diameter. Okay. All right, so traps. These are U-shaped sections of drain pipe that block noxious sewer gases from entering a building's interior through drain lines. These are required at fixtures that do not have integrated traps, and they work by trapping water within them. The water is what blocks the sewer gases. All right, so if you take a look at this diagram that I have right here that I pulled from the textbook, when I refer to a trap, I'm talking about this section of tubing right here, this little U-shaped portion that has this gray section highlighted within it. So this gray part right here is actually water. So whenever you're using water from, let's say, a sink or something like that, the water is going to go down through the drain pipe, but then when you turn off the water, when you're not using it anymore, a portion of that water is going to stay in this U-shaped section right here, and it's just going to sit there. Okay, so now the purpose of this, like this is saying, we have, nasty sewer gases that are going to be coming through these drain lines, and they want to work their way back up through the drain line, all the way up through here, and then escape into the house through the drain in the sink or whatever fixture it is, toilet, anything, because all this plumbing is tied together. This all leads back to our soil stack, which is like human waste and sewage in it and stuff. And obviously we don't want those gases and smells coming through our plumbing and making its way into our air that we're breathing, okay? So the purpose of the water that's trapped here in this trap is when that gas from the sewer lines, when those want to work their way back up through the system and come up here, they're going to be hitting the water right here, and this water is going to block them. Okay, so this is basically acting as a gate that is going to be preventing the gases from entering through here. Or I guess a better term would be a wall. So this is just blocking off access from these gases, making their way up back through your sink and into the air where you can breathe it. All right. Here's just a basic diagram that's kind of showing you how the plumbing within like a bathroom or just a typical house is all tied together. So you can see here we have a restroom and here we have a laundry room. Okay. And if you take a look at this sink and you look at our washing machine here, you can see we have a trap that is attached to the plumbing that ties into both of those fixtures. But then if you take a look at the toilet here, we don't have that U-shaped trap tied to the drain line because the trap is already built into the toilet itself. Okay, so you don't have to add a second trap in because it's already integrated into the toilet. Anything basically other than a toilet is going to have these special traps put into them. All right, and then here's our soil stack. So the soil stack, like I said, this is our main pipe where everything kind of ties into and where everything drains out of. Okay, so this is how all of our wastewater is going to be exiting our house. And all of these waste lines are branching off of it and they're feeding into the soil stack itself, okay? We're going to talk about vent systems here in a minute, but basically anything above the waste lines. So you can see this is the highest waste line in the stack here. We have another waste line here, one here, one here. Anything above the highest waste line is going to be considered a vent, okay? Another term for that is a vent stack, but we're going to talk about what that is in a minute. I just wanted to show it to you here while we're looking at this diagram. All right, so here is the waste system in the entire house for context. So again, number 6 here, this is our soil stack, and this is where all of the drain lines are feeding into. So this is our main point within the house where everything is going to be exiting, okay? We also have the soil stack that will feed into this pipe that's here underground. Okay, so we're looking at the basement floor here, and underneath of the basement floor, we're going to have a drain pipe that's laying under the floor, and everything coming from the soil stack or any other fixtures off of this main drain line will be tied into it, and anything that is exiting as waste will leave the house through that main drain line and go out this way to the sewers or to a septic tank, depending on where this house is located. And then this here, this little Y-shaped section, number 8, that is known as a clean out. Sometimes you'll see those if you go down in your basement and you look at your plumbing. You can actually, it's like a little cap that you can unscrew, and if for some reason you get a clog in your drain line, if you get a plumber out there, they might unscrew that, and then they might run a plumbing snake down through it to unclog anything that is blocking off this waste system. All right, so lastly, we have the vent system. So the purpose of the vent system is to provide air pressure to the waste system. So this air is the actual force that pushes waste through the waste system. So if we did not have a vent system, our waste system would not work at all. So anything, like if we tried to flush the toilet, it just would not work, and nothing would exit the building through the waste system. So we have to have a way for air to get in from the outside into our plumbing system so that the waste can leave in an effective way. Vents are also necessary for traps to function properly. So without them, the water that blocks the noxious gases would be siphoned away. Okay, so if we look at this picture down here, this is what would happen if we did not have a vent tied to our waste system. So here we have that same sink and we have our trap. But since there's no vent coming upward out of this pipe that's supplying an air supply to this, all the water that would normally be sitting right here just gets naturally sucked away out of this pipe, okay? So without any of the water in there, obviously the gases can come back up through here, and there's nothing sitting here to block them, and they can just make their way right out of the sink and into the air, and then you're breathing in all these nasty sewer gases. All right, a vent stack is the section of soil stack that sits above the drain lines. It extends all the way upward through the roof and provides an exit point for sewer gases. Okay, so I explained that a couple slides ago. Here's the vent system in the entire context of the building. So as you can see, the vents are anything above these drain lines. Okay, so here we have our drain line going to the toilet and a drain line going off to the sink and to the tub here, and everything vertical above that acts as a vent. Okay, so like I said, we have to have those vents tied into the plumbing system. So one, the sewer gases that we're creating from using our toilets and stuff like that have a spot to escape, so there's going to be escaping out through the roof. But then they also allow the fresh air to come into the plumbing system down through them, and that fresh air is providing air pressure that's actually allowing the system to function And again, if you did not have them, none of this would work right, and you couldn't flush your toilet, or your sink and your bathtub would get all backed up, and the water just wouldn't go away. Okay, so here's the last section of the lecture. So we're going to talk about some of the design implications that plumbing systems have on us as interior designers when we're working on our designs. As previously stated, plumbing system layouts have an impact on the designs we create as interior designers. For efficiency reasons, plumbing fixtures should be grouped as closely together as possible. That way they can share drain lines. Okay, so you're trying to group everything together in a as close of an area as you can. That way you're minimizing the amount of plumbing lines that you have to put into the building, which is going to be saving on your costs. Okay, one, it's going to save on the costs associated with installing the plumbing equipment. It's less for the plumber to actually put into the building. But two, if you have shorter runs, it's going to be using less water as well. Okay, and the system will be more efficient. In multi-story buildings, the location of plumbing fixtures should be consistent between each level of the building. So for example, bathrooms should be in the same location on each floor, so the fixtures can share a waste stack. Okay, so taking a look at this diagram right here, this is a typical multi-story building situation. So when you're working on design of a ground up building, let's say, and you're figuring out what goes where, you want to take your areas where you're gonna have plumbing fixtures, and you want to group them all into the same general area on a floor plan from level to level. Okay, so if you remember back from one of the earlier weeks, we talked about service cores, like mechanical cores. Those are basically just areas of the building where you have all of your mechanical equipment grouped together. And your layouts for your plumbing system usually fit right into a service core. So you're going to usually find all of your bathrooms and stuff in one central location. And from floor to floor, that's going to be consistent. They're basically going to be stacked right on top of each other. So if you look here on the first floor, we have our toilet and our, bathtub, and then our sink. And then directly on top of that, on the next floor, it's identical. And then directly on top of that, it's identical. And the reason for that, again, is just for efficiency, because everything can be tied together and they can all share a common soil stack, okay? Same for the waste stack over here. So again, the waste stack is the vertical pipe that is not carrying human waste. The soil stack is the one that does carry human waste. But all of these sinks can share a common waste stack, and you don't have like toilets and sinks spread out all over throughout the building that would all require their own vertical stacks, okay? Because everywhere you do that, everywhere you have something off on its own, it's going to require venting to work properly. So you'd have to put in more of these vertical stacks to get them to actually function. So again, by grouping things vertically on top of each other, which is what you should be doing when you're designing, we can just increase efficiency and make the building systems work a lot more effectively. Okay. Plumbing systems can also have an impact on the thickness of walls and the heights of ceilings. So in residential buildings, plumbing lines are typically located within 4 to 6 inch thick walls. However, in commercial buildings, the systems are much more complex and they may require plumbing chases or chase walls. Okay, so we've talked about chases before. A chase is basically a vertical shaft within a building that allows mechanical equipment to run from floor to floor. So a chase wall is going to be 2 walls with a space between them where plumbing lines can run vertically through the building. The width of chase walls can vary, so they can be fairly narrow, or they could be wide enough to provide access for maintenance purposes. Okay, so here's a typical scenario that you would see in a commercial design. So in this building, you can see we have a women's room and a men's room. And the space between these is where all the plumbing that supplies these toilets is being run. So we're going to have our soil stacks within here. Okay, but you can see the way that this is laid out, all the fixtures, like basically our layout for our bathrooms are just a mirror of each other. And the space between them where this chase wall is where all of the plumbing for these toilets is being housed. Okay, so since there's a lot of plumbing lines, you have to have a lot of space here between these two walls so that all of the plumbing can fit. And then sometimes you would have maybe, depending on where this is located in the building, you might have on the end of this wall here, so you have two walls. If this is spaced wide enough apart, let's say on this wall, you would have a door where a maintenance person could actually go into this chase and they could perform maintenance tasks on whatever plumbing is in there. All right, but usually you'll just see when you're looking at a floor plan of commercial space, you'll usually just see a scenario of what you're looking at right here, where we just have two walls and we just have this kind of void space between them where our plumbing is going to be going within the building. All right, so that's going to do it for this lecture. That was a pretty short one. Again, make sure you read through the readings in the book, kind of skim through it and pick up all the main points that I've touched on here. The topics in the book that I touched on in the lecture are kind of spread out through the chapters and they go a lot more in depth. So just make sure you look through all of that and kind of understand how the three systems that tie into the plumbing system function, okay, and what they do. And then also the book talks a little bit more in depth about the way plumbing systems impact the work of interior designers. So make sure you understand all of that and the impacts that it's going to be having on you as you're practicing as a professional. All right, so again, if you have any questions about anything or you need any help, please let me know and I will help you out.